Okay, hi again, everyone. We are get back to the track A. This is track A. We have Sandor. Hi, Sandor. How things are going there?
Hi, Marco. Thanks, fine. Everything
Great,
is great,
great.
yeah.
We are ready for your talk about const. So nice. And I think I can leave the stage, and I add your screen to the stream. And good luck. See you afterwards. If you want any assistance, don't hesitate to ask.
Thank you. Thanks, Marco. Buongiorno, benvenuto. Thanks for joining this session. We'll talk about, let's say, a more beginner but fundamental topic of C++, how to use the const qualifier. So before we jump into the details, let me quickly introduce myself. My name is Sandor Dargo, and I'm working as a software developer in Amadeus, so in the travel and hospitality industry. If you fly, then most probably you already used our services, because we provide, among others, airline reservation systems. I spend most of my free time nowadays either with my two kids, baking a lot, or I write for my blog mostly about C++, Stoic philosophy, and the books I read. And I hope we can, travel pretty soon again. But that's more than enough about myself. Let's have a quick look at the agenda. First, we are going to speak about why using const matters. Then we'll see how we can use const with local variables, how we can or should we use const with member variables. Then we go for functions, return types, and parameters. And if you have any question, don't hesitate to ask at Remo, and we'll cover them at the end, or even after the talk. I will join the Remo for a Q&A. So the question is, why using const matters? And probably you already have a few ideas of this, and we'll cover the whys. But before, we should ask ourselves the question, okay, well, probably using const matters, but should we really make anything const? And the answer is obviously no. We should not make everything const, but we should do better. And I brought a couple of examples from code bases I've seen during my work or on the internet. I anonymized them. So the first example is this. You have the myRate class, and you have this method getNumber of coupons, and it just returns the size of the coupons. Now you see that most probably here we use size on a standard container. Most probably this is a vector. Well, we cannot know from this part, but what's for sure that this size call here, it shouldn't modify the underlying object. So this function should be const. And I know that this method has other problems, because size would return a size t, not an integer. But well, I brought real-life examples. And I brought another one. Here you can already see some consts. So for example, you can see that in this check if special exception, we have two strings that are const, so they cannot be modified. But still, if you look at this code, what we do here, we check if this error has a special exception, and well, we return true, otherwise we return false. This doesn't modify anything in the underlying object, or at least it should not. So obviously this should be const as well. And you might think that, yeah, and we should just return this condition, but I removed some lines of code, some debug logs, which wouldn't modify the object. And you might also argue that this custom error reference should be const as well, because we don't modify the exception, and we should make sure that by accident no one else will if updates the code. So here as well, we should do it better. And well, we have a third, a bit bigger example about this extract phone number from unstructured. Well, it's a bit long, and what it does is that you get a string, and from the string we try to get a phone number, and nothing is const here. Whereas there are a couple of variables like this last digit or first digit that doesn't change during this in this function, and therefore we could make them const. And again, this is a function that doesn't change the underlying object, so it should be const. And you might even argue that we take a string by value, whereas by rule of thumb, well, we could maybe we should take it as a const reference. Well, that part is arguable because I happen to know better this part of code, and usually the length of this string is about 24 characters, which is about the limit for small string optimization. But still, there is a lot of possibilities to add more consts to this function, yet nobody did. So if you go in your code base and you start adding const, you will find, you will encounter a couple of people who will bring up some arguments against using const. And I collected their most usual arguments. So the first one is that they say, well, if I see const everywhere, for me it's just a visual noise. And I think that's not right, because const complements to your code in a way that you cannot express it in any other way, well, in any other shorter way. So it adds something to your code. Therefore, it's not a noise. Like, what would be a noise then? Well, when you declare a member called speed, and then you add a comment to it that this is the speed. Well, that's visual noise because it doesn't add anything, but adding const adds to your code. So it's not a visual noise. Others say that it confuses the developer. Well, I think that using const shouldn't really confuse anyone. And if that's the case, maybe we should spend some time together and clarify the questions. But there is a way how const can confuse the developer, and it's the lack of using it. So let's say that you don't use const in like some of the previous examples, and me as a reviewer or just as a reader, I check the code and I start to think about, okay, why is it not there? Why isn't it const? Seemingly it could be. And then I might think that, okay, const is not used at all in this code base. So probably it means that people working on this project, they just simply don't use it. And then I can ignore the fact that, well, it's not used. But if sometimes it's used and sometimes it's not used, then it's more difficult to understand why it's const, why it's not well, it's more difficult to understand why it's not const. So in that case, you can try to add the const if you're actually working on the code base and use adding const as an explorative tool You can check if it would work by adding const, or if it's a code review, I usually just ask the developer, okay, have you thought about adding const to it? And usually the answer is, no, let me try. So by the lack of const, it might confuse the developer, but that's not a good reason not to add it all to a code base and ignore const at all. And the third one is that, well, it doesn't matter anyway. And well, I don't really want to go into details on this one. There is someone who can explain this much better than I would. So let's have a minute of Jason here.
OK. Now, the problem we have remaining is that it's returning a color struct. So I need to actually get the index number out. And there we have the resulting code, which looks a little bit more than some overhead. Everyone agrees, I think. It's only, well, I don't know, 350 instructions plus a table of data. Does anyone have any ideas for how we might be able to get this to use less overhead? Did I hear constexpr? Can anyone think of a simpler way to get this to have less overhead? What's that? Pre-computed table. Yeah, that could work, but constexpr would kind of get us there, I think, anyhow. So is there some best practice about using const anywhere possible? Has anyone ever heard that? So what happens if we make our static array here of color data const? So if you don't currently use const anywhere you can, I bet you will after this talk.
Okay, and that's enough from the video. So we saw that const is not really a visual noise, and it shouldn't confuse the developer. And actually, it does matter. It might not matter all the time. Well, it won't matter all the time, but it might matter, and it might be significant. So you have some tools right now to face these arguments in your jobs if you need. So besides of those points, in reality, const will help you because it clearly clarifies your intentions. It will say that a variable should or should not be modified later on. Well, it better expresses that it should not, because then we are sure. Or you will know that the function should not modify the internal state of an object. And actually, it's a nice guard for the compiler as well. Because using the const qualifier correctly makes the code easier to understand both to you, well, you as a writer of the code later on, or for the readers of the code as well, and for the compiler too. Because then the compiler can check these guarantees, and it can even execute some optimizations that it wouldn't be able to do otherwise. So this concept that all your let's say all your local variables should not be modified by default is such an important idea. And sorry, I cannot skip this, that even a new language was born out of this. Rust, where you cannot modify by default the local variable, it's immutable by default. And if you want if you want to modify it later on, you have to declare that intention when you declare the variable. So let's start now with const local variables. And the idea here is that instead of a variable that is mutable, like this result, which holds the result of compute result, well, we should make a const local variable, and then we know it should not be modified later on. And this, as I mentioned already, clearly shows our intentions that this is the first and final value sorry, of result. So again, this shows both to the reader and to the compiler that the value of that variable should never, ever change. And you cannot even change accidentally. I mean, you could, of course, put there a comment that, hey, please don't change this. This is the final result. But then, well, anyone can still accidentally change it. With const, it's not possible. And again, this in other languages such as Rust or in other languages, and this is the last moment that I mentioned Rust. Don't worry. This is the default option. And even like the C++ core guidelines says that, well, first, by default, you should make your objects immutable if that's possible. And in another guideline, it says that use const to define objects with values that do not change after construction. So, in fact, the core guidelines also suggest that by default, you should make your local variables const. Now, you might argue, but sometimes it's just not possible, because it might be that the initial value might depend on a condition, or maybe the final value of that variable is computed in a loop. There are techniques to overcome this. You can use, for example, a ternary operator for initializing something with two possible values. Well, you could nest ternaries for even more values, but please don't do that. It's really ugly. It's unreadable. But then you can use instead, like, for example, a helper function, or even an immediately invoked lambda function, a function expression, that will help you to const initialize a variable where you have multiple possible initial values. And you might say that, okay, but it will hurt my performance. It's not really the case with the return value optimization. You don't really have to worry about it. If you visit my blog, there are some tests for it, and it clearly showed that this is not a real concern in most of the cases. And if you initialize your variable in a lambda, then very often you can replace that. Sorry, I said lambda. So if you initialize your variable in a loop, then in many cases you can replace that row loop with an algorithm. But our keynote speaker from today, Sean Parent, could talk much more about this. So let's go to the const member variables now. First question, is that a good idea to have a const member? What could be the reason to have a const member? Well, maybe to show that a member will not change. Okay, it sounds not bad, but let's see what's going to happen if we try to do that. So this is a very simplistic example, but it will show you the problem. There is a class, my class, which has a number member which is always 5. Well, I just wanted to spare the constructor here, but we could assign it in the constructor. Then you have two instances, C and C2, and then we assign C2 to C. Does this compile? Does it work? Well, it does not, because this my class doesn't have, as I hope you can read here, it doesn't have an assignment operator. And well, we didn't manually implemented anything, so it should be generated, and that's true. But the default definition would be ill-formed, so it's not generated. It's because, well, simply you cannot assign to this const member, because, well, it was already initialized, and it's just not possible to assign a new value to it. So this shows the problem that if you have a const member, basically you cannot have the copy or move operations, because, well, how would you move away from something const? This is not really possible. So if you really want that, we'll see that probably you should not. But if you really want that, you can play around. You can try to implement the assignment. You can try to move away from a const member with the help of constcast. But that would lead to undefined behavior, and that's something we don't want. So the standard says that depending on the type of the object, write operation through the pointer, lvalue2 or pointer to data member resulting from a constcast that casts away a const qualifier may produce undefined behavior. So you see here, we implemented an assignment operator, and we take the address of this member, and we cast away its constness. So we get a pointer, and, well, then it's open bar. You can modify it. Well, let's say it works as expected, probably in many cases, but still you depend on undefined behavior, and this is not something you should want. So what can we do instead? So unless you really want to play with constcast, which I think it's like a nice exercise to try, but you shouldn't want undefined behavior in your code, there are some options, like keep your members private. I put the star there because, well, you should keep your members private anyway, unless it's just a data container. And you should also not expose these wannabe immutable members via setters. So you just don't let anyone to change those values from the outside world. And even you should make every function, well, as much as possible, you should make them const, so they cannot be modified even internally, these members that you wanted to be const. Or in some cases, when it might make sense, you can consider using a static const. Why not? Why not when it makes sense? So when does it make sense? Well, when the value cannot change among the instances. So, for example, our initial example where we initialized by default to 5, that member would qualify for this. And also when this value will not change during the whole lifetime of your application. You need a global constant, which hopefully you don't really need. So the takeaway here that const members are for object lifetime, but usually you should avoid using them unless you clearly can state that you want to ban copy and move operations. Otherwise, if you use a static const, that's for a program lifetime, basically. So let's move to the const functions. So this is something that you can use without moderation. There's not much to talk about here, let's say. The const function cannot change the underlying object. That's what it says. So if you call it, it will not change any members, but it might change other objects. That's not restricted. So if you you have a function which creates an instance of another class, on that you can call call non-const methods. That is fine. So the const function, like everything that is const, it conveys a message. It's a guarantee both to the reader and the compiler that the underlying class is not going, the underlying object, sorry, is not going to change. You don't want to modify it, and it's simply impossible to modify it. And again, this is something that the core guidelines advocates for, that by default you should make your members const. But what's the situation with overloads? Because we can overload the function based on the const qualifier. You might have a const and a non-const version of a method, like here. We have this instance O of my class, and we have a const as well, O2. Then we call foo on both. What's going to happen? Well, the compiler will choose based on whether the object is const or not. So for O that is non-const, the non-const overload is called. And for the other one, O2, that is const, in that case, the const overload is called. So we already saw the const cast, that you can cast away the constness. But what if? What if you have an object that is non-const, but you want to call the const overload? Where there's this wonderful line of code that lets you do it. But don't worry, that was just a bad joke. You can use this const equal type o.foo, but actually it's going to work. But before C++17, you can use a static cast, and you cast it to a const my class, and then you can invoke the const overload. And since C++17, you have a much nicer, more readable form of this, stood as const. And you just paste there O, like in the previous slide, O was the non-const instance, and then you can call the const foo. It's as simple. Okay, so let's talk a little bit about the return types. With return types, you have to pay attention, because often you can see that when let's say beginner C++ programmers learn about const, and then they understand that, oh, they should by rule of thumb pass objects by const reference instead of value. They also start replacing the return values. So instead of string, for example, they start returning constring references. But in that case, you really have to be cautious, because if you return a reference to a local variable, basically you return a dangling reference, because this local variable ret will be destroyed when this function goes. When this execution here goes out of scope, you return a reference to something that got already destroyed, and your application will crash. So never return local objects by reference, because they are getting destroyed by the time they could be used by the caller. On the other hand, you might consider returning by reference, by const reference, a reference to a member variable, because that will live as long as this in this case this my object instance is alive. So if you make sure that the returned value will not be used outside of my object's scope, then it's fine. And even in certain cases, well, there is something that is called how is it called? Const reference lifespan expansion or something like that. But you will find, I will share a link later to a very interesting article on that by Arthur Dwyer, that in certain cases it might help to overcome this issue if my object's instance scope is well already ended, but you have a reference. Its lifetime might get extended, but it's mostly, as he called it, it's black magic, and you should not depend on it. So let's talk a little bit about returning a const value. So here we return a const string, not a const string reference, but just a const string. Does it make sense? What would this code do when here foo returns a const string, and then we try to extend it, we try to concatenate with something else, and we want to print, will it work or not? That's the question. What does this function foo show us? What intention does it show? Well, it returns a value. So the caller gets a copy. And that returned object is const. So it shouldn't be modified. That's what it tries to communicate. But does that make sense? And in fact, it doesn't. Like, think about that, I don't know, you buy a house. And the person who sells the house to you says, okay, here's the house, but you can never modify it. It doesn't really make sense. I mean, if you live in the old town of some nice cities, maybe you get those roles, but otherwise, your house is your palace and you do whatever you want. So here you get your own copy, and the communication is that you cannot modify it. Well, it's misleading because actually you can modify it. You see, this const basically gets ignored because you might return the const string, but it's copied into a string basically, and you lose the constness. So don't return const values, because one problem is that it's misleading, and the other one is that it might even decrease your performance. Because here, well, let's check what we do. In our main, okay, we create an instance of something with move, and we want to move into it what foo returns. And foo returns a const, something with move. So what's the problem here? Because everything is either defaulted or, let's say, nicely with some debug logs, it's implemented. But the problem is that we cannot discard. Sorry, we cannot pass a const something with move as a right value reference something with move, because that would discard the const qualifier. It's not possible. So we simply fall back to a silent copy. And most probably, okay, hopefully you don't have such print, so you won't even notice unless you start profiling your code. So we saw that if you return an object by const value, you also communicate something that is misleading, and you might even have some problems with the performance of your code. So we talked about references, we talked about values, we still have to talk about pointers here. They are similar to references, but they're a little bit worse because, well, first, why they are similar. That's something we should cover, because just like we saw that you should not return local variables by reference, you should not also return their address, because then you don't have a dangling reference, but you have a dangling pointer, because when you reach the exit point of the function, well, every local variable will be destroyed. So you point to something that got already destroyed. So you have to make sure the proper lifetimes if you return something by address, if you return a pointer. That's the similarity to references. But there's a bit more to it. But first we do a small digression here, just to mention that we have basically two ways to use the const notation. One is called the east const, and the other is the const west. So east const, in the case of east const, what is left of the const qualifier is the constant. And for the const west, we cannot say anything like that. It's more widespread. I also, because of that reason, I used it in the presentation, but it's also less consistent. So we'll see why. If in this case, like int const c equals 1, you can see that what is left of the const, it's int. So this is a const integer. Well, if you are using const west, then first you write const. On its right, you have integer, and well, still you have a const integer. And it's a bit similar here with the references, but then comes the interesting part with pointers. So int const star pc. What is on the left of const? It's an int. So you have a pointer, in fact, a non-const pointer to a const integer. And with the const west, it's const int star. Next to the const, you have int. Again, you have a pointer, a non-const pointer to a const integer. So what does this mean? It means that we could change, because the pointer is not const, we could change what object we point at, what address we point at, but we cannot change the value at which we point. So then you have int star const cp. In this case, what is left to const? It's the star, so it's a const pointer to an integer. And in this case, it's the other way around compared to what we saw, because the pointer is const, so we cannot change what we point to, but we might change the value there. And for const west, well, we lose the consistency here that I said in the beginning. And we have the, let's say, the double const version, int const, star const, where what's left to the const, in fact, to the const, here the pointer, here the integer, so everything is const, both the pointer and the value that we point to. And for const west, again, we don't have the consistency, because const int star const, so in one case it's to the left, in other case it's to the right, but basically we have a const pointer to a const integer as well. Okay, this is the end of the digression here. So now let's see these different options for the return values. Okay, so int star const func const. Okay, what's gonna happen? The function is const. Okay, that's clear. The returned pointer is const, but the data we point to can be modified. And the problem is that type qualifiers are ignored on function return types. And here the return type is a pointer. Okay, we return a pointer, and the const is ignored. we even get a warning, which hopefully is not just a warning, but you interpret it as an error in production code. So it will say that, well, the type qualifier is ignored. So in fact, this const was not taken into account. And as you can see, we could do whatever we wanted. We could change what we point to, and we could even point to something else. So this doesn't really work. Now let's see what's going to happen with the const int star. Again, here, well, we have a const function, which is not, okay, I know it's not really necessary here, but as the core guideline says, we should, by default, make every function const. I just want to emphasize on this message. The return pointer can be changed, but the data itself is const. And in this case, the constness is taken into account. Hence, the compilation of this piece of code is going to fail because changing the data that we point to is not allowed. Yay! This was taken into account. So what's going to happen when we have this double const version where both the pointer and the value is const? Well, it's a similar behavior compared to a previous example. The function is const. The return pointer, well, the return pointer can be changed, but the data cannot be, because the constness of the integer is taken into account, but the constness of the pointer is ignored. Okay. So again, we have a compiler warning on the ignored qualifiers. That was about it, the const return types. We saw the references, the values, and the pointers. Now let's finish with the const parameters. So the non-reference type parameters, constness, can be ignored, as we'll see here. And I think I miss a slide here. That's my fault. I will send to Marco the corrected version. But what I wanted to show here is that when you declare a function foo, which takes a const integer, okay, the implementation will be probably in a different file that as a caller you don't see the implementation file. And if there you use just an integer, not a const integer, it means that this constness is ignored. And I would say don't use this feature. I know that in this case we take this integer by copy. So the original integer, what we pass in, is not wouldn't be modified anyway. But by putting here const, we communicate to the caller that in the implementation we don't want to change that value. We want to use it as he sent it, and actually we fail. We fail in terms of communication. We communicate in something, and we don't hold ourselves to what we communicated. But luckily, this with references or pointers would not work. This similar example would fail. So this is very misleading, and you shouldn't use it. But luckily, okay, for references and pointers, const is not ignored. And even if you have like two overloads in with const and non-const ints. Okay, you cannot mix this up. The class type parameters that are const should be passed by rule of thumb as a reference, because copying an object, so if you take it by value, you will copy it, and that copying is more expensive than passing the reference in most of the cases. So as it's in the most of the cases, you can treat it as a rule of thumb, and in the rest of the cases, you will probably learn it on the fly when you should use value instead of a const reference, like with the small string optimization, or you might pass a string view instead of a const string reference. Those, I would say, are edge cases, especially in a sense that they would seriously impact the performance of your application. But if they do, then you might not comply with the rule of thumb, which is okay. So by default, you take your object type parameters by const reference. But if you would later have to modify it, and not the original, so not the original, but what you use only inside of your function implementation, then in those cases as well, you can take them simply by value. But okay, if you are reading such a code, you might wonder if it was on purpose, if you expect a string by value, is it on purpose, or is it because you forgot something? Well, maybe it's good to add some comments there that well, we take this by value because we have to modify it. But okay, let's remember to what the core guideline says, that by default, pointers and references should be consts in function parameters. So don't do this. So if you take I don't know, something by const reference, and then you have to make a copy because you have to modify it and you have to use those values, then it's really not worth doing this. Instead, you can just take it by a value, and probably you make a comment why you take it by value in the function documentation, so that you don't raise some questions for the others. So we have 2 minutes left, and it's time to conclude. Using const is useful, just you have to know the rules. And we saw there are really not a lot of rules. Well, for member variables, we should rather not use the const unless we don't want to copy and move the object. But for the functions and for the local variables, we should use the const without moderation whenever it is possible, because it will help both the reader and the compiler to understand the code better. And well, for the compiler, the understanding will help it to optimize away some parts, which is great. For the return types, you have to be cautious, because you really don't want to return something dangling, and you have to make sure that you deal with all the lifetime issues. And for parameters, I would say that if it doesn't make sense because you have to create a new copy anyway, then you don't use the const. You just take it by value, and you avoid creating another copy. Okay. So you can benefit from const to achieve certain things, like to improve the maintainability of your code, because it's easier to understand. It's easier to maintain. You can improve the const correctness, obviously, of your code by adding more const to it. And you can also use it as an exploration tool. So whenever you are not sure if a certain piece of function, for example, a certain function or some piece of code, well, are modified later on, or well, some variables are modified later on, some functions modify the object or not, you can add just the const. You can try to compile, and you will see. And if it fails to compile, then you know that well, in that 1000 long function, that variable is modified somewhere, and then you can check why and how. Otherwise, well, you just gained the new const variable. So thanks a lot for your attention, and I'm going to answer if there's any questions. I think in the room.
Yes. Thanks, Sandor. Thanks. We have a few comments and a couple of questions actually. Let me start with the questions. Well, one is from Yuri. Well, the questions are both from Yuri. One is why const cast is not deprecated if it leads to undefined behavior most of the time. So what's your feeling about this?
Well, I think it's there, my personal opinion, that one thing is, you said it's most of the time. Most of the time it leads to undefined behavior, but not all the times. So they don't remove the possibility to use it correctly. That's one thing. And the other is that it's already used, probably they don't want to break code. Like it's something similar compared to what Sean spoke about this morning. It's difficult just to remove something. I know it happens sometimes, but
yeah, it would be, I think, impossible to deprecate such a huge cast operator. So it would be very hard to remove it. Once is
there are many cases.
Yeah,
so.
you can remove auto pointer, but removing a cast operator is kind of impossible. And well, probably the comment from Yuri is why not deprecating, meaning that it's not. Well, I think there are use cases where const cast is useful, but as you said, many of them are implemented in a wrong way. So probably is not a priority for the committee to address. So probably I have some return in my headphone. I don't know if it's me or. Well, I don't know. I don't know if it's me or it's you, but no worries. Another one is another question is well, it's are you east const or west const? Okay, Yuri wrote left or right.
Well, look, in terms of like coding guidelines and coding style, I always follow what's there in the project I work for, and we are working on something that has been there for 30 years. And therefore, it's a const west, so I just use whatever is there. I don't want to confuse people with that.
Okay, so I have also we have a few comments, and okay, we have a comment from Leonardo is saying that the operator is not deprecated because but the standard says that is dangerous. That's I think a clever comment. So probably it's something stated in the guidelines. And thanks, Leonardo, for this comment. And we have.
Yeah, well, in the standard, I quoted from the standard, so it spoke about that it leads to undefined behavior.
Yeah. Okay, we have actually another comment by. We have two comments actually. One is from Roberto, and one is from Yuri. Let me start from the comment from Yuri. And well, it's not really a question, so I don't I don't put the emoji with the question mark is a comment like this. It's saying, well, I don't know if it's a question actually, because it starts with, is it recommended to declare a parameter without const? And when implementing the method, use the const qualifier, because we want to prevent modifying that parameter. Probably it's kind of a question. Yuri, if you can clarify what, if it's really a question or if it's a comment. That's the. Okay, it's a question because we have some limitations in the length of it. Okay.
Well, I think it doesn't hurt. I mean, if that's your intention in the implementation, then it helps. But I would just match the two, and I would put const in both cases, both in the declaration and in the implementation. I think it's easier to understand when you see the same things.
Yeah. Okay. And well, I think we don't have questions anymore. Yeah. Let me check the Q&A. No, we don't. But Sandor, I think you will be available in the networking for some time.
Yes.
So you'll have a table for follow-ups about this. And okay. So thank you all for attending. I get back to this track in 20 minutes, more than 20 minutes, and we have another talk by Roy. We have a break now, so half an hour break actually, and enjoy the rest of the conference. Thanks, Sandor, for being with us, and enjoy the rest of the talks. Thanks a lot.
Thanks a lot for the
Cheers.
possibility. Bye bye.